In this video, I'll talk about a cop, a police officer, catches a speeding car. And we will be talking in terms of physics. And the physics, you should be able to calculate how long does it take for a cop to catch a speeding car. Or what is the distance traveled, or how much the distance the cop has to travel in order to catch the speeding car. So what is the information given? The information given is this car is driving with 90 mile per hour in a 75 mile per hour zone. Of course, it is a speeding up. So in a 75 mile per hour zone, the driver is moving with 90 mile per hour. And the police officer here is at rest. The moment the police officer finds out this car is speeding up, it starts accelerating, and the acceleration of the police officer is 2 meters per second square. So we know the initial condition of the police officer, the initial velocity of the police officer or the cop is 0, and the initial velocity of the, whenever I say the velocity and the speed, sometimes it is in the same direction, so it is exactly the same thing here. So the speed of the car is 90 mile per hour and the acceleration is 0. What does that mean? That means this car is moving with a uniform velocity. It is not changing with respect to time. But for the police officer, it is at rest and then starts accelerating. What does it mean? That means the police officer car speed will be increasing with respect to the time. As the time increases, the velocity or the speed will be increasing for the police officer. So how long does it take for the police officer or the cop to catch the car? Let's say the distance traveled is s and it catches the speeding car after time t. So we have to find out both the distance and the time. So we have to solve the equations. So now let's write down the equation first. So first I'm going to solve for the driver. And this one is given in mile per hour. So we have to change this one to SI unit. And what is the SI unit system? That is in meter per second. So velocity of the driver is 90 mile per hour. And you need to understand what is 1 mile means. The 1 mile in terms of the meter is 1609.34. Okay, so 1 mile equals to 1609.34 meter, and 1 hour means 3600 seconds. So if you solve it, what you get is 42.23 meter per second. That is the speed of the driver. And what is the acceleration of the driver? There is no acceleration. And why is that? Because the car's the velocity is not changing with respect to time, so it is 0. So once I write down this equation, I'm going to use this equation here. S is equal to v0t plus half at square, and S is the distance, so that is S. The initial velocity, v0 means the initial velocity, and which is this velocity here. Do not get confused by the v0 and vt here. That is exactly the same thing. This notation, whenever I write something in this bracket, that means there's a formula, and you need to understand what the meaning of this one is. v0, the v0 is the initial velocity or the starting velocity, and the car and this is for the driver, so it is 42.23, and this is the time. The acceleration of the driver is 0, so this term will vanish. So we'll have this equation now, 40.23 times the time. We do not know S and we do not know the time. Now let's solve exactly the same thing for the cop here. What is the velocity of the cop or the police officer? It was 0 meter per second because it was sitting stationary. And the acceleration of the police car is 2 meter per second square. So we're going to use exactly the same equation of motion. But for this case, the initial velocity of the police officer is 0. But it does have some acceleration here. And what is it? The acceleration is given, which is 2. So this 2 and this 2 will cancel out. So we'll have this equation now. S is equal to t square. So now we have two equations, the equation 1 and equation 2. Two equations and two unknown variables. So how do we solve this one? So I'm just plugging the value of S into this equation here. So let's do that. So instead of S, we'll use 40.23 t, and then you will have t squared here. So if we solve, we'll get is there are two equations, the two solutions. The one solution we'll get is 40.23 seconds, and the other is you will get is 0 second. The 0 second at these two times, look at the difference here. At these two times, the police officer and the car will be exactly at the same position. What does this mean here? Time equals to 0 second. The time equals to 0 second refers to this location here, past location, and you see both are exactly at the same position. And time, and this time here, 42.23 seconds. Again, they are exactly at the same position here. So the time equals to 0 second does not make sense here. That's not meaningful. Okay, so the only thing that makes sense, because this one was moving with a uniform velocity, and the police officer now is speeding up and catches at this location. So we are interested at this position here. So now we have the time. That means the police officer catches this speeding car after 40.23 seconds. So I'm just going to plug this time into this equation here. You can plug into this equation too. Either one, that is perfectly fine. So 42.23, and the time is again 40.23. If we solve it, we get 1618 meter, which is close to 1.62, let's say, kilometer. So the police officer, this police officer or the cop catches after moving 1.62 kilometer distance. That's how much he has to travel in order to catch this speeding car. Okay, and now we can also find out what is the speed of the police officer when it catches the speeding car. So how do you calculate this one? The way we calculate this one by using this equation now. V equals to V0 plus AT. And this V, what is this V is? That's the final velocity, or the velocity, or this, let's say the speed at which, or the time the cop catches the speeding driver, which is the VC. And V0 is the speed of the car or the police officer at the time equals to 0 second, which we know is 0. We have just calculated, or we know the acceleration, which is 2, and the time is 40.23. If we solve it, what we get is 80.46 meter per second. 80.46 meter per second. If we change this one to mile per hour, that is 180 mile per hour. So when the police car is exactly at the same location as the speeding driver, this is moving with 180 mile per hour, and while this one is still moving with 90 mile per hour. Okay, because this one was speeding up, or there is an acceleration, the speed keeps increasing. So at the time it catches this speeding driver, the speed of the police driver was 180 mile per hour, while this one is 90 mile per hour. So you can get more intuition from this graph here. So this is the time here, and this is the position. So this line here for is the driver, the blue one is for the driver, and this one has a is a line here. What does the line means here? So that means the driver is moving with a uniform velocity, uniform speed here. Okay, and this one is a quadratic equation here. Okay, so speed is now increasing up. At each point there's a positive slope here. Okay, at each point there's a positive. If I draw a tangent, that means a positive slope, and it keeps increasing. So at this point, when both intersect, that means at this position the police officer catches. Okay, so this is how you solve to find out the distance and the time for a police officer to catch a speeding driver, and go through each part and make sure that you understand each and every step here. So this is it from this video here. Again, if you have any questions or comments, do not hesitate to ask me questions or write down your questions or comment in the comment section below. And do not forget to like, share and subscribe the channel. Thank you.